General Today we will see general model of shared memory programming. Shared memory is a memory shared between two or more processes. Shared memory is an efficient means of passing data between programs. Depending on context, program may run on a single processor or on a multiple separate processor. Now first general model is process creation and destruction. The first requirement of parallel processing is to generate a number of processes. Now how many processes are required? On that basis we are create the process as per requirement of problem. After completion of that process we are destroy the process. So destroy the process when parallel part of process is completed. Now first primitive for process creation and destruction is id equals to create process and the value of id will be different in a different process. Now how many processes can be created? So process 0, 2 and -1 where id equals to 0 indicate a parent process. Second primitive is join process n comma id where n is the total number of process. id is identifier written by create process call. Second general model is mutual exclusion. In a shared memory programming, access to shared area must be properly coordinated. Now, example for shared memory. Example is critical section. We want to access the shared memory. So, how we can access the shared memory? So, for that we are using mutual exclusion. So, what happen in a mutual exclusion? If one reads a location, it must be ensured that no one reads that area till one finish the update. The primitives are init lock id, second primitive is lock id, third primitive is unlock id. So lock should be declared as a pointer and allocate a space from shared memory pool. Now first primitive is init lock, initialize the lock. Lock id attempt to lock, unlock id unlock the lock and return. Now example is producer consumer. So at a time only one can update, whether producer can update or consumer can update. Now example is producer. Now first one, whenever producer want to insert data, so first one he need to take a lock id 1, then perform the operation insert into share struct. After completion of operation unlock the id 1. Second example is consumer. If consumer want to consume the data, then he will first lock id, delete from shared stock, unlock id 1. So at a time only one can update the producer or consumer. Now third general model is barriers. It is intended for a group of process rather than two process. No process may proceed into next phase until all process ready to proceed to next phase. It is a basic mechanism for synchronizing process inserted at the point in each process where it must wait. The primitives are barrier, bar equals to barrier init and procedure. So create a barrier structure and return a pointer. Second primitive is barrier is the call to be done by each process which has to go through the barriers. Third primitive is clean barrier. It invoke for every barriers created to clean up any shared memory and semaphores. Allocate to implement the barrier. So these are the three primitives are used for barrier. So in a clean first one we want to create a barrier. So we are taken one example is project. So in that project there are number of phases. So first one we are giving the barrier to the number of phases. Suppose barrier is given for phase 1, then phase 2, then phase 3. So first one we are creating the barrier for each phase. After that completion of that phase, we will continue that barrier. Now complete our all phases.